Hi, good morning, and welcome to our presentation. Today, my name is Francesco Cappilli. I'm from SIMICO S.p.A, Infrastrutture Milano Cortina. Today, we are going to showcase our work in progress digital twin called Engineering Digital Twins for Milano Cortina 2026 for the Winter Olympics that will be in Italy in February 2026. The name that we assigned to the project that is we are building at the moment is SimicoTwin. That is a fantasy name, but the scope is perfect for us. So we are trying to engineering the future on-demand digital infrastructure using a mixed infrastructure, digital infrastructures. So also in Epic Unreal Engine 5 for the visualization and also for the content. Before starting, I am the head of digital governance and engineering in SIMICO. So our idea is was to make the availability of the project for the normal people, for the ministries, for ones who want to access to the data in real time. To be more sustainable, also for the information that we provide on the construction phases. The preface is that we have a bunch of 96 infrastructure projects, mainly divided by game venues. There are 31, legacy 20, and viability infrastructure that are 45. If you open that link here in the QR, you can also see the Open Milano Cortina. That is the geographical advancement for the project in Google Earth. Going further, this is agenda light for today. I'm talking about our technological vision for over the Olympic venues. So we are trying to create a unified pipeline from Microsoft Azure Common Data Environment, Autodesk Construction Cloud, and Bentley Cesium for the fast rendering in GIS. Today we are showcasing the use of DataSmith and other on-the-fly importers that we are using at the moment. I want to mention one of the newest technology that is present now from that open technology, that is Fragments. Fragments is reducing significantly the size of BIM models, and there is a new plugin in Unreal that is called Fragment Unreal. I will present the use case for that, the best practice that we are using on it. And of course, the geospatial content, so the world management, because we have entire cities rendered in real time. As you see in this photo, this is Cortina d'Ampezzo, and we don't have the covering of Google Earth and not Google 3D Tiles, so we recreated from OpenStreetMap's data. Of course, the automation and real-time data and of the tenant integration in Microsoft Azure, mainly, and the pixel streaming use case that we are monitoring now for performance, and the case study that we're presenting here. So before starting, this video shows the event distribution in Cesium. So we have more than 3.5 billion investment, public investment in the venues, and the number that I mentioned before, divided in Lombardia, Veneto regions, Bolzano and Trento provinces. And you see here the Arena of Verona. That is one of the most iconic projects that we are building at the moment. We are revamping. So talking about the unified data pipeline, optimizing the data lake that we have. Before starting, I want to make you aware about the data lake that we at the moment we manage. This is a data sharing environment, 3D and not 3D. The not 3D is the data lake connected the common data environment that is a digital platform mainly based on Microsoft Azure, and that collects and stores the data from the construction site safety informations and are provided by the companies involved in the works. and are continuously monitored by the relevant authorities like Guardia di Finanza, Carabinieri, Police, Antimafia. Is connected real time with them, so they can access to the data and then go to the site to verify the data. We have also an advanced artificial intelligence chatbot and behavior system for the controlling of this data. This chatbot enables real-time monitoring and also the graphic that you see here. So the authorities can go there, see the data, see if it's coherent for the construction phase. This is the data lake for the documentation. We have also of course, the digital DNA is the BIM data, so the 3D data lake, and is connected to the first one. Of course, you know the levels of BIM. We have the simulation real time, so the VBS for the BIM 4D, the fourth dimension of BIM, so the work back down structure for the construction schedule and real time progress tracking. The BIM 5D that I know, you know, it's an integrated cost database for the cost controlling and payments. Of course, any BIM any BIM model has a number of prefab elements that has a unique ID, UED, that are the core of our Unreal Engine based digital twin, because it's connected to the 3D data via UED. And of course, you know, the clash detection for reducing the costing in situ, because we mitigate the errors. You see here the bobsleigh, that is the most iconic construction we are doing in Cortina d'Ampezzo. It's a relevant investment for the Italian minister, and it will be done before of course this year ending. And a very important part is the environmental social metrics. So this is a sustainability strategy for a practical retired framework, corporate investment and community. So the ESG, that is the core of this digital twin that I will showcase with you today. It's something that is related to context analysis, a deep context analysis with real world constraint and opportunities, not only for the maybe ideal path of sustainability, but for actionable focuses. So something that is concrete and related to the concrete path of the construction. Of course, this is connected to the ESG social metrics for the World GRI, so the Global Reporting Initiative. This preamble to go to the sustainability path. We are building here in Cortina the Olympic Village, that is a massive sustainable installation here. You see here it's a mobile and modular design, so it has a temporary village engineered on the airport of Cortina, and will be completely revamped then after the games. So it's a zero impact legacy designed for complete post-game disassembly. And of course, you can also offer adaptive reuse, so a flexible post-game plan allowing temporary reuse, balancing immediate community needs for long-term ecological commitments. Here, the reality, and here this is what we are creating on a real engine for the previous part. So you see here cesium connected to the models in BIM, and not only, of course, for the pre-visualization and visualization, but the connection between the data lake and the site advancement, and also the connection to the relevant authorities that can scrape that data. For us, it's a simulation of the entire life cycle of the venue. So not only the graphical, but the life cycle in the entire part. And we think that this project that is in early phase, because we started 3 months ago, could be very impactful for Italian history for that in technology, because it's something that is a new way to represent project. Digital twin, you know what is digital twin? So the digital twins represent a dynamic, continuously updated virtual replica of physical infrastructure, and we create them from connecting BIM models to the sensoring and to the environment. So this adoption of digital twins for us is something that is going to optimize the life cycle management of infrastructure. We want to reduce maintenance cost, enhancing reliability, and ensuring high standard of efficiency and resilience over the long term. So the next part is connecting also to the sensoring and real-time sensoring through Unreal Engine or other platforms that can be hosted by a technology part. You see here the BIM models. So for the arena, for the Livigno is one of the venues, the city of Livigno, sorry, this is Cortina, I mistaken, and this is the part of Lombardy Livigno, and this is the digital twin recreating in a real engine that we showcase in the next slide. For us, it's, as I mentioned before, a sustainability driver. So we want to simulate energy efficiency. We want to identify and mitigate conflicts in early stage. We would like to accelerate project delivery to meet critical paths and also to share real-time data with stakeholders. So it's very important to check to connect with stakeholders and that their level of technological implementation is important for us to receive the coherent data in BIM, of course. This enhances for us the digital accessibility, and also is important for the visualization, as mentioned before. We started using that in Rimini. I'm sorry, but it's stuttering a bit here. And with the main scope that we found here was that the families were very connected to the digital twin. So they were very interested to use the city of Cortina virtualized. So we understood that this part is very, very important for normal people to understand how this is done. This is done with connection with data. This is done with connection with 3D data. And of course, if a kid can play with it, it's a good part for us because it's very simple to understand what we are doing and not only creating graphical representation that are normally more technical. I'm sorry, but it's a bit stuttering. So innovation through technological leadership and vision. This is the Stadium of Cortina. Was built in the last century, and they are revamping completely for the disabled people. So we would like to create, using an hybrid technology, an operative system for the venues. I don't know if there's a good term for that, but it's something that is connected through different parts of technology implementation. We have more than 27 venues that we are building inside that, of course, using mixed reality and also BIM authoring tools. We would like to connect and handling massive data, so the data of ISG, the data from CDA, and the data from IoT for connecting like temperature, supporting the other things related to the IoT and also to BMS, to building monitoring systems that can be connected through digital twin over a real engine. And of course, we want a real-time accessibility for that. So you can stream that, not related to the hardware, but you can pixel stream that. You can load on your browser, and you can load wherever you are with the connection that you need. You see here the bobsled in a real engine with the inspection part of all the metadata. We need some performance that we have in issues here because it's a huge model, over 100 gigabytes of IFC and Revit files. So imagine that is huge. But Unreal is very fast to import with Datasmith. And for us is perfect because we can stream on the context of the reality of the entire city in Cesium or on Unreal. We are on-demand streaming. We are committed to the on-demand streaming, as mentioned before, like pixel streaming. So out of monolithic application, proprietary type application, we are doing an in-house application for that. That is something that fits our needs. And open standard, because our scope is to fulfill the open standard that is required by the Italian normative and the European for IFC and other open data that is needed for the maintenance. Going further, also for simulation. So we are not directly committed to the simulation of bobsled, of course, but we are trying to play a bit with the context inside that. So it's working very well because it's very immersive and it's something that is forecasting a new technologies that can be used for AEC industry, for us, of course, and maybe replicated to other players that are in Italian public administration. We would like to do some cutting edge, of course, because it's a bit fostering about the future that is not available at the moment in Italian market. So we are opening a bit the road for that. So it's an early phase for the project because, as I mentioned, it's only 5 months that we started. We have 6 months to deliver the venues, but we are running on it, and hopefully we can join that in time. This is another venue, Vaselga, and this is for representing the unified data pipeline that I mentioned before. So we connect the data from ACC through direct download or with the Datasmith. Of course, you can just connect if you are able to use Datasmith proficiently. It is for us a strategic shift, so that can be connected through Datasmith or through IFC. And of course, this is something that is fostering what we are going to do. So as mentioned, not only representation, but something that you can play by yourself and see what is the situation in the development. You see here also cesium. Where is cesium present? I left the icon to understand when it's done and when it's done with PCG. Going further, we want to integrate the open source solution. You see here a path of the ski lift. It's not complex because it was not visualizable. And you see here in Cesium, you can just import the data from OpenStreetMaps directly, and then you can rewrite this a bit and re-engineer with the PCG. Going further, this is the parking in Livigno, and it's one of the biggest projects because it's 530 cars host. And it's working very well on Unreal Engine, of course. So it's something that, as mentioned before, lets us to render in real time also the space management for that. So we want to understand how the space management is done not only in ACC, but or in other authoring tools, but also in Unreal to see what's the behavior of the real situation for that. Of course, it's a video that I prepared here very early, so no much lighting calculation. Fast format is something that I'm very committed to because we have the huge amount of data that we have to process. You see here the entire distribution of the project in Livigno. So the parking, the ski, and also the lake. We are creating an artificial lake that is forecasting data. Forecasting the water to the ski park. We create a material here for let the inside be visible. So you can just do in Unreal in 2 paths because we use water material, but it's very representative to go through visualization to connect the data and make the data visible also to people that is not so technical. This is the connection with the entire city recreated for Cortina with PCG. So PCG, as you know, is procedural content generation for a real engine used by many technologies like foliage, building recreation. This is a plugin that we built by ourselves to recreate from the footprints of OpenStreetMaps. And the data is inside, so the beam data are completely inside that and are coherent because they are GIS coordinated models inside that. We created also here for this type of importing an app for us that is converting the data from IFC directly in GLTF and splitting into JSON and GLTF, because the size, as I will show in the next slide, is reducing hardly. So I present 3 importers for your knowing. I don't know if you know them. The first one is the SIMP. It's a SIMP. It's an importer for 3D data. If it supports like more than 57 different 3D formats on the fly. Supports the static meshing and dynamic mesh, asynchronous loading, EFC with metadata. But here we have the problem. So they are incoherent, because maybe there are some incoherence in the GitHub code. And so I will show you that importing IFC is over 2 gigabytes of data inside the RAM of the digital twin. So it's very, very heavy to render. The second one is our method we implemented. So we connect to the Azure, stream the data, so with the converter in GLTF, and exposing it, the metadata connecting to the UID to the 3D data. So you can just scrape that, JSON or CSV, and then GLTF. The size here is 7 megabytes for a project that is 400 megabytes. So you can understand how it's the cost of hardware is reducing for this implementation. The third one that I want to showcase is from Hyro, that is present here. Is building the plugin for this scope. So that open, as I mentioned, is an open source community that is creating a new binary standard for BIM. It is converting IFC to the fragments. Fragments size for this 100 is 5 megabytes comprehensive of all metadata. So it's lesser than GLTF and JSON, of course. And it's very impactful because it's running on mobile at the moment in Android, imported from Azure, and it's rendered like a visualizator that we can build on the fly and load from async, so from our tenant. It's already ready, and also it has all the presets for that. So very useful for us because we have a huge amount of models and maybe 200 models to load. Okay, so we are talking about hundreds of gigabytes. So reducing them for us is the winning case for using in mobile in situ. On site, sorry, in situ it's in Latin. This is the pipeline for fragments. This is our visualization in JavaScript in Node.js. You can just freely download on that open community and use by your case. Supporting all revision of IFC, connected to the data lake, connected between dynamic meshes or static meshes. And this is the path. So you can freely convert that on the visualizator in Node.js. The fragment can be loaded inside Unreal directly. So you can download from GitHub the plugin and use by yourself because it's very, very reactive for the scope. So it's a bit a confrontation of these standards, the data Smith, the GLTF runtime, ASIMP, and fragments. Of course, we are using them, data Smith and fragments. Data Smith for coherent data, for the previews, for changing material, and fragments to use on the fly for the size packaging that we need. Of course, these one are not fully compatible for us. So let's going further. We'll talk about geospatial context, world management, and pixel streaming. I'd like to showcase also the pixel streaming today. You see here the venue of Livigno, how we created that. So the normal workflow for you doing that, you import the 8 map, you model it and then change material, put the vegetation, the foliage, etc. This is the normal path that can be done. The second way is to create the artificial intelligence metadata-driven importing. So we use also plugins here that recreate the typical from Livigno with PCG. That is the normal type of houses that you find here, wood and concrete, and they are represented normally in the Alps, in the Northern Alps, so Switzerland Alps, Italian Alps, and also Austrian Alps. They are similar. The importing of all OpenStreetMaps and then converting on the fly with PCG. This is another plugin that is very useful. It's called Landscape Combinator. You can just put your GitHub here, and you see here it's imported into Livigno Avenue with also the ski parks. You see here the ski parks that you can ski, and then we see the evolution of the foliage with the simulation of the snowing path, so you can just see the mitigation of that and the changing from the summer to the event of the winter. Of course, they are imported from OpenStreetMaps. They are automatically generating buildings with variations, so you can variate them with the seeds. And then you can import images from satellite. The result is very, very promising for us. So, and also cost saving for the hardware. And we are catching also this for importing in massive way. This is from from Bentley Cesium, the Arena of Verona. And here we have the covering, like in Milano and Verona, we have the covering of Google Maps and Google 3D Tiles. Where it's present, we can also scrape the data from the geo content, like the street names can be catched in real time. The 3D data from last scan we import from our tenant, but you can also use Ion from Cesium to host that and also IFC. For our case, we use a mixed and hybrid solution, so the Cesium base and the Unreal for importing last scan and the LiDAR and the BIM with their data inside the datasmith. Of course, we can mitigate that importing like in fragments, but will be showcased in the next month, understanding if it's better. This is the lake, so a simulation of the lake that you see in the higher part of Livigno, more visually rendered. So we used a prefab from Fab. So we bought that for using that and recreating a bit the environment. Okay, let's go to the automation. I think that is one of the most important things that we are trying to do. So real-time data and simulation. You see here, we want the connection between the data lake. This is the bread production in Cortina that is becoming an apartment for the Comune of Cortina, for renting to people. You see here the inspector by changing all the materials, but it's connected also to via HTTPS request to the data lake. So you can scrape the data from data lake from our data lake in tenant of Microsoft Azure and exposing it via Power BI via widget and also calling related to the connection with the BIM data. So if you touch a BIM data, you receive the data, you connect the data lake inside that, and you have the real-time data in evolution. You see Microsoft Power BI as a widget here. This is the site advancement for the construction that will be ready early 2026. As you see here, Unreal is very fast also to render extra widget. So we don't need to open Chrome. We just can open the window, and then when it's done, we can close that. The data are connected, of course, via data lake on HTTP request, so we can connect also sensoring. Going further, sorry. This is the event that we did in Rimini and showcased the technology splitting 2 monitors. So that was a big monitor, like 100 inches, the first one with the 3D data from the city, and then the second monitor with all the data from sustainability. So graphics, this type of graphs are done directly into Unreal. So it's importing the data from data lake and recreating the graphic in real time. So you can do by downloading CSV, pre-downloading CSV, or via HTTP request, so it's reading directly from Azure. This was an event that was hosted also for our Olympics athletes. So they were present, and they did some interviews for the presentation of them. So it was also helpful for them to present to the people that were present in that meeting. So I'd love to load the pixel streaming if it's working. Sorry, because today it's a bit stuttering. You see my screen? So this is in real time. And we choose 6 venues at the moment because 27 is very hard impactful, okay? And if you move that, you can just click on the venue and then exposing the data inside that. So the data, as mentioned before, are downloaded directly on CSV now because it's faster, but it's already connected to the tenant, so it can read the real-time data. Of course, when we have the sensoring connection, we can choose and click the 3D data from BIM and having also the informative data from the sensors. I will showcase the bobsled. So it's under the city. Yeah, you can see here the entire city rebuilt. And you can move freely on that, showing the evolution of the bobsled and also the geocontext. So you see here the entire city of Cortina, and then you can move on the waypoints that you want to visit. And also the stadium that is most iconic, one of the most iconic venues that we are doing that. So this part is done with PCG, because we don't have the covering of the Google 3D tiles. So we rebuilt on that using artificial intelligence and typicals. Okay, the last part is the mobile app that we are building now. We are still building, okay, because we are changing the technology inside that. So you see that you can move, inspect, and also using Cesium in the mobile app. That is very interesting because you load on Android or iOS the context, the geographical context. Okay, I'll leave you a small video how is done for the augmented reality and also extended reality in mobile. So there are two use cases: the augmented reality in Unreal that is becoming very, very attractive for us because we can stream the data. The data at the moment is DataSmith, so it's a huge model. It's a bit heavy to load, okay? But using the new formats like GLTF for fragments should be winning because the models are streamed by the tenant and are some megabytes rather than gigabytes. And you see here, you can move that Also, you know that it's the normal context of the augmented reality use, and but you can click on the BIM data and see the data that are present on the BIM family or BIM component. I can load and stream the disciplines, so you can just put on off when you want to inspect that. So also map, structural, turn off the architectural and see that. And also the data, if you click, you can inspect that. This is on revamping at the moment because we are trying to use fragments Unreal to do that. And I think that will be very fast to do the scope. The second one is a bit more complicated because it's it's a multiple choice of Android, in this case, or iOS. You can just freely move with the first person or the third person to inspect that. So we have a different level, as you see here: the drone, the first person, or the inspector for the third person. Of course, also here we have some problem of stuttering that is dependent of the size of DataSmith models. And as you know, you cannot load the DataSmith on the fly at the moment. It's not compatible with Android. And so also for this case, the use of fragments Unreal will be very, very useful for us. As you know, it's like a first-person experience when you can just do your experience in mobile, moving on the Android and seeing that. Sorry, go a bit further. And as you know, we can also stream the Cesium content here, so it's geolocated and it's representative also from his position in the world. This is the third person. So it's more like a visualizator. You can just move that, touch it. When you touch with 2 fingers, it moves. When you zoom in, pitch and zoom, and it zooms on the venue. And so we are creating a mixed data scraper and also visualizer. So the first one, the most important, runs on pixel streaming, and is the huge content, the big one. And the second one is all for the mobile, and it's more related to the EFM and also the in-situ inspection. So going further and concluding the open standards. We are committed to open standards as a public administration for moving from beyond the strict proprietary formats. We like too much to use also GitHub, of course, for storing our project and sharing as is possible, of course. And we foster the use of fragment for the future because it's for us it's cutting edge and very important. Of course, we are open to community collaboration in the public administration because we would like to maintain some part of the code opened in the future. This is something that is connected to the opportunity to do the conversational AI that was present yesterday. I was not aware about that, but in real, so we'll be in the editor in the next reviews. We would like to implement here, so you can just speak to the digital twin and receive the information inside that, rather than connecting and touching the things. Of course, it's useful for the AFM, so electronic facility management for that. So we are in the next month we are connecting to the data for that. And then, as the appendix, I would like to showcase the protocols that we are using at the moment for your utilization. Okay, pixel streaming, you know, DataSmith, DSSimp that at the moment is not working so well, GLTF that is reducing for us the runtime code. And so because we are importing and converting from IFC OpenShell that is from the Bonsai, from Blender. So we did that tool to convert automatically with AI. And also the fragments So you can just use that freely and the plugin. Cesium, of course, for the context where is present 3D tiles. PCG, and also landscape combinator that I was not able to insert for the presentation today. So thank you. We are our engineering team. And so I would like to thank for your time to hear me today, because for our side it's an honor to be here in Stockholm with Epic. And thank you for your time for connecting with me. If you want do some question and answer, it's the time.